Hi guys, welcome back to the channel. My name is Jack, and in today's class we are going to continue with our Math 8 content. Today's topic is on the scientific notation. Okay, so you're probably wondering what a scientific notation and what does that mean, Jack? So basically, the scientific notation method is used when numbers are very large or very small, and this is just another way to actually write out the number. It's kind of like a shorthand form. Okay, so first off, we're going to start off with these positive numbers. Okay, so everyone can see what I'm talking about. Okay, so I'm going to take an example here. So let's try this one. Okay, so let's do 540,000. Okay, so this is my number here, 540,000. Okay, so the decimal place is actually after the first non-zero number. So the decimal place is actually like right here. Okay, right after the 5, and you're going to move the decimal place to the right, okay, all the way until I get to the last 0. Okay, when you write this out, it's going to be 5.4. I don't need to write out all of these zeros, and it's always going to be a base to the power of 10. So move it to the right and then count how many times you're moving it. So let's do this together. The decimal place can only move in between the numbers. Okay, so it's going to go 1, 2, 3, 4, 5. Okay, when I write it, it's going to be 5.4 times 10 to the power of positive 5. Okay, whenever you are actually moving the decimal place to the right, okay, that's when the exponent is positive. Okay, let's try one more, and we're only going to do the positive exponents first. Alright, so I'm going to take this off here. And let's try this number. It's 48,900. So instead of putting the comma, I'll just leave a little bit of a space, okay, so everyone can see that. So again, the decimal is after that first non-zero number, which is the 4. Okay, to make this whole number, again, I'm actually moving the number to, or the decimal to the right. We're going to count the number of decimals or places. 1, 2, 3, 4. And you're just moving it until the last 0. And I always put an arrow so I know where it's stopping here. Okay. This time, because we have 4, 8, 9, I actually have to write down all of the non-zero numbers here. So I'm going to write 4.89 times 10. Okay, and we moved 1, 2, 3, 4 times. So 10 to the power of 4. Okay. And you see that it is actually easier and faster to write it in scientific notation as a base of 10 rather than writing the whole number out, okay, like over and over again. Alright, so that looks good. Okay, with that, let's try maybe one more example here. Okay, let's try 89,560. Okay, so I'm purposely putting all these non-zero numbers just to show you the difference. Okay, so it's going to be 8.956 times 10. Okay, I'm going to move the decimal place one more time. It's right after the 8. Okay, so 1, 2, 3, 4. So it's 10 to the power of 4. Okay, and you notice I wrote 8.956. I have to write all of the non-zero numbers, okay, at the front here. If there's a 0 after that, I don't need to indicate the 0 here, okay? And this actually has to do with the number of significant digits, and that's something that you will encounter in high school, okay? So with that, let's try some examples where we have really small numbers. So these are like really big numbers, okay? So let's start off with a simple one here. So let's try 0.009, okay? Now I see that the number is like really small, okay? So what we're going to do here is, again, the number or the decimal is right after the first non-zero number. This is where the decimal is hypothetically, okay, and I'm moving the decimal to the left. Okay, so we're going to count how many times. So 1, 2, 3, and I'm stopping basically where I see the decimal here. Okay, so I'm going to put 9.0 times 10 to the power. I moved 3 times to the left. So when you move to the left, the exponent is actually negative. Okay, so to the power of negative 3. Okay, so just like this. Does everyone see that? Okay, so you're hypothetically making sure that the decimal is right after the first non-zero number. I'm going to move it to the left and count the number of times you're moving it to the left. Okay, and the exponent is just going to be negative, okay, for the really small numbers. Okay, let's try one more here. Okay, I think everyone is getting a really good grasp, okay, of this concept. So let's try 0.000. I'm just going to add some zeros here. Let's put 26. Okay, so I purposely added some extra zeros and an extra non-zero number. So again, the decimal place is hypothetically right after that non-zero number, which is 2. I'm going to move it to the left until I get to where the actual decimal place is, okay? So we're going 1, 2, 3, 4, 5, 6. I'm just going to move this down. So this time when you write it, okay, 2.6, okay, times 10, okay? And you start from here, okay? 1, 2, 3, 4, 5, 6 to the power of negative 6, okay? So it is actually really important that you remember these rules for writing scientific notation. Okay, you will encounter this in high school as well. The teacher will already expect you to know what scientific notation is and how to basically write out these numbers in scientific notation. Okay, so these are basically really small numbers, okay? There can also be really large numbers, and it's just another method for you to write it down, okay? Let's try actually one more example here. I'm going to take this off, okay? And I'm going to add some more non-zero numbers here. So let's try let's try this one. So it's 0.00216. Okay, I'm just gonna leave some space so we can see it, okay? And make sure your hypothetical decimal place is after that non-zero number, which is 2 here. And you should always do it this way, okay? And sometimes teachers in high school won't let you use a calculator for this section because they expect you to use a little bit of mental math, and you should already know how to write it out like this, okay? So again, we're moving it to the left, okay? So let's write out the number first. So 2.16 times 10, okay? And again, write out all the non-zero numbers. I see 216. I have to write 216 at the front, okay? So now we're going to move the decimal. So it's going 1, 2, 3, 4. So it's to the power of negative 4. Okay, everyone sees that? Are there any questions here? Okay, so I just need to remember when I'm moving to the right, okay, the exponent is going to be positive. When you're moving to the left, the exponent has to be negative, okay? That looks good actually, okay? So this is basically writing each number in scientific notation, all right? And the second part of the questions are saying to write each number in standard notation. So let's try a couple of questions on that. Okay, so this time they're actually giving you, the question is given in scientific notation. So let's try this one. So it's 2.66 times 10 to the power of 4, okay? And I'm changing this into the standard notation. So this is the scientific notation, okay? So let's just write the number out here so we can see it. So I'm going to put 2.66. So I notice now that my exponent here is positive. So again, when it's positive, you're moving to the right, okay, 4 times. So we're going to move the decimal place. 1, 2, 3, 4. Hypothetically, that's where the decimal place is going to be, okay? And you see how we have these loops in between? Wherever you see a loop, I'm adding a 0, okay? So I'm going to put 0 and 0, okay? So when you're changing this to the standard notation, the actual number is 26,600, okay? And again, if you want to just put like commas in between, put the commas between every 3 numbers here, okay? Or most teachers will just leave like a space in between, all right? And that's how you are changing it back into the standard notation. Okay, let's try a question where we have a small number, okay? So let me just take this off. Okay, and you can see that the concept is actually very simple. Okay, let's try 7.5. times 10 to the power of negative 5. Okay? So I'm going to write the number here. So this is the number. I don't need to write the whole thing out. I'm just writing 7.5. Okay? Again, I'm looking at this exponent here. The exponent is negative. Okay? So again, when it's negative, I'm moving to the left 5 times. Okay? Because it says negative 5. Okay, make sure you make your loops actually really big, okay, so you don't mess up with the number of zeros. So 1, 2, 3, 4, 5. Okay, does everyone see that? And I'm purposely making these loops really big. That way I can see how many zeros I have. So I have 1, 2, 3, 4 zeros, okay? And you should actually put a 0 also like before the decimal place as well. Okay, so there are 4 zeros here. So it's actually 0.0000075. Okay, so I'm putting 4 zeros right there. Okay. And again, you can see basically these numbers because they're really small. Okay, and say I'm doing some calculations in class or basically in the lab. I don't want to mess up with the number of zeros that I'm putting, or if I leave out a 0, that actually makes a really big difference when you're doing various calculations in the lab. Okay, so it is actually always easier to use scientific notation. Alright, so one more time, scientific notation used for really big numbers and really small numbers. Okay, questions can ask you just like this. It can ask you to write each number in scientific notation. At the same time, it can also ask you to write each number in standard notation. So I should be able to do both of these methods and change them back as well, okay, to each other. Alright, so that looks good. So if there are no questions, that does bring this video to an end. I hope everyone enjoyed the content and you did understand how to write these big and small numbers in scientific notation. Alright, make sure you're doing a lot of practice questions again from the textbook. Try some of the application and thinking questions as well. So thank you for watching this video. Don't forget to like, share, and subscribe. And I will see everyone next time. Thanks. Bye.